Today, in this video, we will see numerical, a cylindrical piece of steel 80 mm diameter and 120 mm long is subjected to an axial tensile force 70 kN. Calculate the change in volume of the piece if bulk modulus is 1.7 into 10 raised to 5 Newton per mm square and Poisson's ratio is 0.3. Diagram for that numerical is a circular bar of length circular bar diameter capital D, length capital L, axial tensile force denoted as P, a piece of steel 80 mm diameter, D is equal to 80 mm and 120 mm long, L is equal to 120 mm, is subjected to an axial tensile force of 70 kN. P is equal to 70 kN, 70 into 10 raised to 3 Newton. Calculate the change in volume of the piece if bulk modulus is K is equal to 1.7 into 10 raised to 5 Newton per mm square and Poisson's ratio is 0.3. To find change in volume, for finding this change in volume, first using relationship between E is equal to 3K multiplied by 1 minus 2 mu. 3 into K is 1.7 into 10 raised to 5 multiplied by 1 minus 2 into mu is 0.3. 3 into 1.7 into 10 raised to 5 204 into 10 raised to 3 Newton per mm square. This is Young's modulus. Now, area for that circular bar is pi by 4 into d square. D is this 80 mm. 80 square. Pi by 4 into 80 square. 5026.55. 5026.55 mm square, and volume is area into length. Area is 5026.55 into length is this 120 mm. Therefore, 5026.55 multiplied by 120 603186 mm cube is volume, and stress sigma is load upon area. Load is this 70 into 10 raised to 3 upon area is 5026.55 is equal to 70 into 10 raised to 3 divided by 5026.55 is 13.93 Newton per mm square. Now next find change in volume. For finding change in volume, use relation volumetric strain is equal to change in volume to the original volume. Therefore, change in volume is equal to EV into V, and EV is for bar subjected to uniaxial stresses. EV is E into 1 minus 2 mu into V, and E is stress upon Young's modulus 1 minus 2 mu into V. This is change in volume. Stress is this 13.93 multiplied by 1 minus 2 into 0.3 multiplied by volume is this 603186 divided by E is this 204 into 10 raised to 3. One minus 0.6 into 603.603186 multiplied by 13.93 divided by 204 into 10 raised to 3. 16.47 mm. Change in volume is 16.47 mm. See, for that circular bar subjected to uniaxial stresses, original volume is 603,186 mm cube and change in volume is 16.47 mm for subjected to 70 into 10 raised to 3 Newton axial tensile load, and Young's modulus is 204 into 10 raised to 3 Newton per mm square. Stress is 13.93 Newton per mm square. So, for that circular bar of diameter 80 mm and length 120 mm and axial tensile force P is 70 kilonewton. Bulk modulus means volumetric stress to the volumetric strain is 1.7 into 10 raised to 5 Newton per mm square, and Poisson's ratio is 0.3. Young's modulus is 204 into 10 raised to 3 Newton per mm square. Area is 5026.55 mm square. Volume is 603186 mm cube. Stress is 13.93 Newton per mm square. See the stress formula. If this area increases, stress decreases. Stress is inversely proportional to this area of that circular bar. If we increase area of that circular bar, That means if we increase this diameter of that circular bar, then stress also, if we increase diameter of this circular bar, then stress is less. Relation between stress and area is inversely proportional. If area increases, stress decreases. If area decreases, stress increases. Stress on that bar. What is stress? Stress on that bar. Stress acting on that bar after axial tensile force given to that bar. This is change in volume, 16.47 mm. See here also, see relation between formulas. EV is equal to change in volume to the original volume. That means volumetric strain is also inversely proportional to original volume of that bar. Thank you very much.